In the last video, we looked at variables, coefficients, and terms. In today's video, we will be combining that knowledge when we look at polynomials. Polynomials are expressions that have variables and coefficients. These expressions cannot use negative exponents or division, but can have addition, subtraction, multiplication, and positive integer exponents. So let's look at some examples of polynomials. Let's say we have something like 5x. So we have this term here, 5x, and this is a polynomial because we have our variable x and coefficient 5, and we're using multiplication. We don't have any negative exponents. Of course, our exponent here is just 1, and we're not using division, it's multiplication. So this is a polynomial. If we had an expression like x squared minus 4x plus 5, we could also classify this as a polynomial because if we look at each term, in our first term we have x squared, and of course here we have our positive integer, which is 2, and here in our second term it's negative 4x, and we're using multiplication here. It's negative 4 times x, and there just be a positive exponent 1. And finally, we have our last term, which is 5. There's no multiplication or division, it's just 5. And so since this fits the requirements of a polynomial, x squared minus 4x plus 5 is a polynomial. If we look at something like 7, you will notice that we just have this number 7. There's no variable. We're not writing x or y or any other letter next to the 7. But this is still a polynomial because 7 is the same as 7x to the 0. And this is because x to the 0 is the same as 1. Anything that is raised to 0 is of course 1. So this is the same as 7 times 1, which is of course 7. Now, if we look at another example, we have 4x divided by 3. So this term here is not a polynomial because we're using division, and of course in our definition, polynomials are expressions that cannot use negative exponents or division. And this term here is also not a polynomial, x to the negative 2, because we're using a negative exponent, which is negative 2, and this is the same as 1 over x, 1 divided by x squared, and this uses division. So we cannot classify these two as polynomials. So now we will be using our knowledge of terms to look at monomials, binomials, and trinomials. So a monomial just has one term. It's a polynomial with one term. So this could be something like 3x, where our term is just 3x, x squared, y squared, or something like x. So as you can see, we just have one term. With a binomial, this is a polynomial that has two terms. So it could be x plus 5, where our first term is x and our second term is 5. We could have something like 3x minus 7, where our first term is 3x and our second term is negative 7. Or we could have something like x squared plus y squared, where first term is x squared and the second term is y squared. A trinomial is a polynomial with three terms. So this could be x plus y plus z, or 3x minus 5 plus y. So we're looking at polynomials that have one term, two terms, or three terms. But what about polynomials that have 4 terms or 5 terms or 6 terms? Well, there's actually no name for these polynomials. There's no specific name. All we have to do is, so if we have a polynomial that has 4 terms, like a plus b plus c plus d, we just call it a four-term polynomial. But if it was a plus c plus d plus e, as you can see, we have five terms, a, b, c, d, and e. So this would be a five-term polynomial. If it was a plus c plus d plus e plus f, there are 1, 2, 3, 4, 5, 6 terms. So it's a six-term polynomial. So basically, after we deal with our three terms, it's just a pattern where we have the number of terms in the polynomial and we just add that to term. So if it was four terms, it would be four-term polynomial. If it had five terms, it would be a five-term polynomial. Six terms would be six-term polynomial, and so on. So now we will be looking at the degrees of polynomials. So first, let's start with monomials, just a single term. If we have something like 3x squared. So to identify the degree of the term, we have to take the sum of the exponents of the variables in the term. So in this term, we have our variable x, and this is raised to the 2. Our exponent is 2, so that means the degree of the polynomial is 2. But if we have x squared y to the 3, so in this polynomial, or in this monomial, we have x and we have y, and the exponents are 2 and 3. So to calculate the degree, we have to take the sum of the exponents of all the variables. So that's 2 plus 3, which is 5. If we have something like y to the 7, this would just, of course, be 7. Or something like a squared b squared c would give us 2 plus 2, which is 4, plus 1 is 5, since we are calculating the sum of all the exponents on the variables. So that's what we have to deal with for monomials. But for binomials and trinomials and four-term polynomials, so all the other polynomials, when we take the degree of the polynomial, we have to look at the term with the highest degree. So if we look at an example where we have 3x squared plus x, so we have to first look at our two terms in this polynomial, 3x squared and x. And to find the degree, we have to look at the degree of the of each term and find the term with the highest degree. So our first term has a degree of 2, and our second term has a degree of 1. So that means we have our highest degree here, which is 2. So that's the degree of our polynomial. In our second example, we have x squared y squared plus z. So again, we have to look at the degrees of each term. So this is 2 plus 2, which is 4. And this z here, our exponent is 1, so that's 1. So our degree is the term with the highest degree, and that's 2 plus 2, which is 4. So this is a 4, the degree of this polynomial is 4. In our next example, we have a squared minus x plus 7. So now let's look at the degrees of all these terms, and we know we don't have to worry about our 7 because when we're dealing with the degrees, it's just variables. So a squared and minus x. So a squared, this degree here is 2, and x the degree is 1, so our degree will be 2 since a squared has the highest degree. In our next example, and this is the final example of the video, we have a four-term polynomial. So as we know, this is the same rule for monomials and trinomials. We have to identify the degree of each term and look at the term with the highest degree. So our first term has a degree of 5 plus 7, which is 12. Our second term has a degree of 11. Our third term, negative n to the 13, has a degree of 13. Our final term has a degree of 2 plus 5, which is 7, plus 3, which is 10. So the term with the highest degree is negative n to the 13, because 13 is the largest number here. That means our degree of this polynomial will be 13. So I hope you enjoyed today's video and you now have a good understanding of polynomials. In our next video, we will be looking at like terms, and if you have any questions, please leave them in the comment section below. Thank you.